Thank you. Hello, Tokyo. How are you guys doing? Hopefully that coffee kicked in and we can get in some real things to talk about. So the sign of a good CEO is he wants to solve big problems. Rohit came on board. He talked about solving big problems. I'm an engineer. I'm here to solve problems. So let's get into what it takes to actually build a data architecture that can help solve the problems that the previous presenters were talking about. Ready? Okay, let's go. So there are a few technical trends and business trends we are seeing in data management. The first one I want to talk about is, which was talked well about here, is the hybrid architecture need that everybody is talking about, the hybrid data architecture. What does this mean for all of us? Everybody here is concerned about getting locked in to a particular cloud provider, AWS, Azure, Google, and they are also constrained by the fact that I cannot move all my data to the cloud. I don't want to get locked in to any of these providers, and I want to keep some data on-prem is the requirement for every data manager that's out there. I'm sure all of you guys are thinking about that, right? What this means is I want a data architecture and a data platform that helps me be in multiple clouds as I need them to be, and also have a lot of my data on-prem because that's where I feel the data is secure. The second important trend is about performance and reliability with concurrency. So let's say you're starting out in your data architecture planning for the future, and you go with a particular provider. You start playing around with it. You like the way the database works. Let's say it's Snowflake or Redshift. You like the way it works, and you start implementing stuff, applications, and code on top of it, and then you want to go to production with it 6 months later or whatever, right? You want that same platform to work when you were playing around with it with 1 or 2 people, to go to production and expose the same thing to 1,000, 2,000, 10,000 people working on the same database. Concurrency is a very important performance characteristic that everyone now is looking for. So make sure you guys are aware of what that means. Thousands of concurrent workloads, thousands of concurrent queries going against the same database and expecting the same performance of less than a second or a 2-second performance for that query is what you should be looking for. Performance and reliability at a higher concurrency level. We all are worried about cost. Our on-prem solutions that we currently have, whether it's for an enterprise data warehouse or for an OLTP system, is very expensive, like Rohit mentioned. A lot of all of us and around the world, we are moving away from this expensive appliance-based enterprise data warehouses to a more commodity-based software which I can buy and use when I want it and pay for it when I want it, not when I'm not using it, right? So that's an important trend. So TOC, or total cost of ownership, compared to an existing on-prem enterprise data warehouse should be a lot better. That's a main pattern or a trend we are seeing. And the fourth one is I don't want to go hire expensive DBAs or very highly skilled people that I will find very hard to keep. So I want a system that is easy to manage. Please manage and host the database for me. Expose SQL or JDBC or an ODBC connection for me. You performance tune it. You maintain it. You monitor it. You upgrade it. And I just want to consume and use the data that I want to use with it. That ease of management is becoming a very important pattern in all of the future data platforms that we should all consider. So we did, Jeff Wies here, he's our Chief Marketing Officer. He conducted a survey of IT data managers around the world. And this is what they are saying about the needs that they have for the future of data management. Everybody thinks it's cost that's important. The number one thing that every manager is worried about is performance. Like I said, I don't want the performance to be good now, but when I put all my users on the system, I want the performance to be really good. Performance is the number one thing we should all look into while implementing a new data architecture. The second thing is security. What does security mean to all of us? When I'm moving data on the wire, over the network, this data needs to be secure because we know hackers are out there. And the real hackers are the ones that are inside the company, not outside. So security means encryption of data while it's moving from one computer to another, which is data in flight. And security also means encryption of data while at rest, while stored on disk. You need to look for a data platform that is secure end to end. There was a lot of talk about edge. You can put a device that is sitting out there by the beach. Nobody is monitoring it, but it's connected to your network. That edge database needs to be secure as well because I can, as a hacker, go in there and hack into it if it's a flat file and connect to your network and disrupt your entire process. Edge security, core security is very important according to a lot of the data managers. The third thing that's important is all about flexibility. I don't want to pay for a system when I'm not using it, is one important criteria. So we all come into the office at 7 in the morning. You guys work hard, okay? So in Japan, you guys get in at 7 in the morning, and you go home at 6. And that's when you work, let's say. From 6 p.m. to 7 a.m., the systems should not be, I don't need the system. Let's shut it down. And I don't want to pay for the money, right? But pay for that system and it's up and running. And give me that flexibility in cost. Give me the flexibility also for scaling, automatic scaling. From noon to 4 p.m. is when all my users are hitting the system. I need 200 compute to take care of that. Other times, I just need 10. This again is a cost play, but give me the flexibility to go up and down, even during the day, so I can scale and manage my costs, and also my SLAs and expectations with the customer. So performance, security, and flexibility are important characteristics you should look for. This was a surprise to me. In the same survey, we asked the data managers, where does your data reside? on-premise and multiple clouds was the number one answer. Show of hands, how many of you have data in multiple clouds and on-prem? This is the norm. This is where the trend's going. Like I said, the number one requirement was I don't want to do a cloud lock-in, right? Because what if AWS charges more tomorrow? I want to have the flexibility to go to Azure or Google or even bring data on-prem. So that's the criteria we need to look at. On-premises and multiple clouds is the number one deployment methodology for data. On-premise and single cloud is the next one. So what this talks about is the need for hybrid data management platform. A data platform that can exist in multiple clouds and on-prem and help you solve your data needs. Why is all of this important? Why is the trends in data management going where it's going? In the past, we used to deal in terms of transactions. A company would measure itself based on how many products it sold. I sold 1 million databases software today. I acquired 2,000 customers last year. Woohoo! Great. They would pay bonuses, they would pay everything based on that, and they won. Great. But it's not good enough anymore because what if I bought that piece of software, I'm the customer, I bought that piece of software, took it, I didn't like it, I put it on the shelf. Never used it. And then I go to LinkedIn and Twitter and say, this product is horrible. Never buy it. Because I bought it, I spent $1 million, no use. So that company, even though they sold 200,000 products in a year, they started going down. And they could never figure out why. The future of data management is not just about transactional data, that is the yellow box. It is also about merging and joining the transactional data with this whole notion of behavioral data to gain insights into the customer. How many of you have customers here? I'm sure everybody does, right? We all have to deal with customers. Knowing the customer better, using their behavior patterns, when they would buy, are they happy with the product? What is their values? How intrinsically they look at certain things. Is performance important to them versus cost? All of these data should be collected and is being collected now. And they are using that in the sales process as companies. The third thing is the social data, right? Twitter, LinkedIn, Facebook. All of this is where all of us go and interact right now, WhatsApp, right? There is a lot of data that can be pulled from this to understand patterns in geographies, in locations, in certain parts of the world, and also about topics that are interesting, right? So going forward in modern use cases and modern applications, like a customer journey, like a hyper-personalization, these three types of data needs to be merged to produce the right analytics. Make sense? But these three types of data have their own data characteristics which we all should understand before we go in with the data architecture. Transactional data, as we all know, resides in ERP systems. It needs fast inserts, quick updates, and quick small selects, correct? Behavioral data, and by the way, transactional data in ERP systems can reside on-prem or in the cloud. Behavioral data is mostly about the algorithms, the AI or the ML algorithms are used to mine transactional and social data and generated patterns about the customer, saying this customer wakes up at 6 in the morning every day, and this customer reads emails between 7 and 10 in the morning. So when I'm sending a marketing campaign, when should I send it? It should be around 7 in the morning, right? So on and so forth. This behavioral data is getting collected using machine learning and AI algorithms and stored in on-prem systems, and they use this behavioral data to join with the transactional data to produce any kind of activity. So in the case of customer journey or hyper-personalization, they will join these two data to produce a marketing campaign, to produce answers to valuable customer or not, so on and so forth, okay? So you need to build a data platform that is capable of real-time updates, fast ingestion, quick access, available in multiple clouds and on-prem. I just complicated your life 100 times. But I'm here to solve problems, like I said. So let me start with the solution and not talk about problems anymore. What we all need is an operational data warehouse. And this is where Actian can really help you guys. An operational data warehouse has these following design principles built in to its existence. Number one is data agility. How many of you are dealing in your lives with data scientists, business analysts, and people like that? Okay, in your data management problem, if you go talk to your folks, you will be dealing with data scientists and business analysts and CEOs and executives. They all have different needs for the data. A data scientist needs data which is atomic, extremely bare data. Don't curate it. Give me the data as you saw it, because I'm going to use techniques to mine the data. A business analyst cannot deal with that amount of data. So data scientists can deal with hundreds of billions of records in a database. Business analysts cannot deal with that. They say, aggregate the data, give me a higher level of data, and then you move things up as you go. Data agility means the data platform needs to have the capacity to handle atomic data, aggregated data, UI data, and even executive level data in a handful of a second and be able to provide that to the user, okay? That is how you make a company move the way you move it. Like Amazon knows everything about 200 million customers they have in their warehouse. So they can give you a UI when you log in and say top picks for you and show 10 products there. And they do this for hundreds of millions of their customers. How do they do it? They use data agility and built into the data platform that they have. We need edge computing as an important characteristic, as we talked about. Data doesn't reside in the data center anymore. Data resides in hundreds of devices that are out there in the edge. So we need a seamless connectivity between the core or the data center and these edge devices be able to pull data from the edge, do the analytics, and push the analytics back out to the edge devices so they can be intelligent. The edge device could be in a point-of-sale credit card machine. It could be in kiosks, like Rohit mentioned, or it could be in connected cars that are moving around all over the world. Usability and ease of use is an important characteristic because administrators don't have the time to manage this mass of data by doing manual stuff. So ease of use is an important one. We talked about hybrid being in multiple cloud. Also, hybrid means dealing with multiple data types. Time series is an important function that you need to have in the data platform, as well as structured and unstructured data types. Performance at scale is an important characteristic, as well as what we talked about in terms of total cost of ownership. So when you look at an architecture, this is the meat of it. You're looking at personas you got to deal with at the left. These could be data scientists, business analysts, and so on. You need to have the capacity in the data platform to let them use their own tools. If you tell a data scientist, use Java, they will resign and go to your competitor tomorrow. Right? The data scientist wants to use Python or R or KNIME or these kind of tools and not be restricted. So give them the flexibility in tooling. From a data ingestion standpoint, every company these days have standardized on Spark or Kafka or certain ETL tools. The data platform needs to plug in and enable these out of the box, integrated, to help data ingestion happen seamlessly through existing open source software. You need to have the language flexibility as well as SQL access into the operational data warehouse. The core is the operational data warehouse in the middle. It needs to have two capabilities. One is the cross-engine orchestration across various engines, and you see the engines on the right. And it needs to have persistent storage in on-prem storage devices like HDFS, which is the Hadoop distributed file system, or on cloud storage like S3, ADLS in Azure, or Google File System in Google. Now, the operational data warehouse exposes SQL. SQL is still the main language for analytics. Yes, Python and R are catching up. So this operational data warehouse needs certain capabilities around how to build it around. So columnar is an important thing. So you got to have a columnar engine that helps you store data in columns. It's an important one. Row is the traditional database storage engine, the row engine. You need that. I get it. But you also need unstructured engine in terms of a NoSQL engine that can process unstructured text data to be plugged in. You need an edge engine like our Zen product, as well as you need machine learning and data, and AI engines to be built in. Why do we need all of these to be separate? Because we want flexibility. I might need columnar today, I might not need row today, but I want to use columnar, and I want to bring this up as an engine, as maybe even a containerized engine, 100 instances of these, because that's where I'm storing my data. I want ML and AI, or deep learning engine, because I want to bring the compute of what we run for machine learning algorithms-wise to where the data is and not have to move the data to where the algorithm runs, maybe in a cloud somewhere, right? So I want to bring the compute for machine learning into where the data lives. So to tie all of this together, you need a data fabric. A data fabric is like a Spark engine, which can connect to multiple different sources and provides parallel data movement across these engines. So data fabric is a key component in your data architecture. So these principles is what we have built the Actian Avalanche on. Actian Avalanche is a managed cloud data warehouse available in AWS, very soon in Azure. How many of you here work with AWS already? Nice. How many of you work with Azure? Equal amount, not bad, right? So again, multi-cloud, right? So Avalanche is a cloud data warehouse that you can try right now for free, and I would really like for you guys, every one of you here, to go to actian.com/avalanche and try out for free the cloud data warehouse, actian.com/avalanche. And if you do that, you will get the data platform that you need for your future needs, which is totally integrated and managed by us, and you will get the setup in 20 minutes. You go to actian.com/avalanche, sign up for a free trial. In 20 minutes, you can be starting to load data, terabytes of data, into a scalable platform that gives you all of these features, and you don't have to manage a thing. It also has, compared to, so this is where we compete with the Redshift and the Snowflakes, right? It has, our advantage is performance at scale and all of the principles we talked about, but we also have an integrated data data movement suite where you can automatically source data from Salesforce, NetSuite, and all of these SaaS applications, as well as your on-prem databases, and move it seamlessly into Avalanche for analytics without much work. If you go to Snowflake or Redshift, they would say, go talk to our partners or start writing code. But over here, we have integrated data movement, highly scalable data movement built into the platform. So once you have the data access and move data in, you can shut it down and pay nothing while the instances are not running. So you get the flexibility in the cost as well, so that you pay for what you use and when you use it, and not when you're not using it. On that side, you would see your favorite business intelligence tool. We partner with Looker, Tableau, Click, and all of your favorite tools, including Microsoft Power BI, that you can easily plug in these tools and start visualizing the data that's already in the platform. You can plug in your favorite data science or machine learning tool, like a KNIME. How many of you here have heard of KNIME as which is an open source data science tool? I see a hand going up. Good. KNIME is natively plugged into Avalanche to do parallel high processing computing. So you don't need to pull data from the database into the KNIME studio and work there. You can do query pushdown to make it really fast and scalable. So you can do data science coding, visualization, whether it's in Python or R or your favorite language, with Avalanche. So it's a scalable platform. This is exactly what you guys need to think about for your future data needs. So I do ask each and every one of you to go try out actian.com/avalanche. So Gartner recently introduced this whole notion of third generation computing. The first generation data computing was all about on-prem, scalable data platforms on appliances. That was what Teradata, that was what Exadata was built on. But that is of the past. And then there was second generation data warehouses that came on board in the cloud that gave you the flexibility, like a Snowflake and a Redshift. But once you turn on the load, they became cost prohibitive. Third generation data warehouses, which is where Actian Avalanche leads from a Gartner standpoint, gives you the flexibility at the best cost for performance. We differentiate a lot, in the technical side. I can get into that a little later, but we differentiate a lot because we have implemented our database to be vector-based processing. We leverage the CPU and the CPU cache, not I/O or RAM, and that gives us 20 times better performance on the same machine that you run your Oracle or your Teradata on, because our database is built from the bottom up for leveraging the latest CPU functions. Just that gives us a 20% or 20 times performance advantage over all of our competition. So leveraging that piece of technology with the managed service gives you the scale that you're looking for. So Actian Avalanche Cloud Data Warehouse, like I said, you can go to actian.com/avalanche and sign up for free. It gives you high performance on a pay-as-you-go model, and it's delivered as a managed cloud service. You don't need to go hire a DBA. You don't need to go buy hardware. You don't need to purchase software. You don't need to manage or monitor or upgrade or performance tune. Everything is taken care of. We give you an API or a way to connect, load data, start using SQL or Python or R or anything that your favorite tool is. So closing out, it's got the best TCO of any cloud data warehouse. On the right, you see a comparison of how Actian performs on the x-axis on the number of queries that you need to run concurrently, on the y-axis, the cost. The blue line shows a linear growth of cost as you increase the workloads. That is the Actian Avalanche curve. The red line represents Redshift. And look at the cost going up. As you increase the workloads, just look at the cost going up. This is what you have to write in a check every day to Amazon if you use Redshift as you increase the workloads. We are all the same around 50. So if you run 50 queries concurrently, we're about the same. You go to 100, you see the divergence. So total cost of ownership is important. And you get it with the third generation of cloud data warehouses like an Actian Avalanche. So build, and when you think about building new applications with analytics or rewriting existing applications, think about these characteristics that you see, which measures your total cost of ownership. Then comes data integration. I want to quickly talk about data integration trends. This is the ETL that we do. How many of you guys are aware of what ETL is? So Informatica, right? Man, that's expensive, right? But we all have to live with it, not for too long. So data integration trends here are, I want to source data from anywhere. Like I said, multi-cloud is a common trend. My data resides in AWS, in Azure, in AWS in an S3 bucket as a JSON. That's where I store all my machine logs. In Azure, in an Azure Data Lake store. On-prem with ERP systems and other databases that I use. For my analytics, I need to be able to source data from all of these disparate sources, different data types, and easily help me map that and bring it into my data warehouse where I can actually do a lot of the analytics work. So sourcing data from anywhere is becoming a big trend. The second trend is easy to use guided integrations. I'm moving data from Salesforce into the data warehouse. It should be easy. What we provide is a guided template where you can drag and drop in an UI, Salesforce to Avalanche, a guided template. You just fill in the blanks, and there you go. We have all done ETL. This takes months of coding to do, right? We can make it happen in minutes for you guys. So guided integrations is an important concept. The next one is all about edge computing. We talked a lot about edge. You need a data integration trend. One of the important ones is processing data at the edge, analytics at the edge, running statistical models at the edge, collecting data, doing data cleansing, so garbage in, garbage out problem is solved right there, and processing data to do some scoring at the edge. This is the statistical modeling part. But all of this is great only if you can secure the edge. One of the important, or one of the more popular ones that are getting used in the edge as a database is SQLite. How many of you use SQLite here? I see a few hands going up. There was a report published in December where every instance of SQLite was susceptible to a hacker attempt because there was a serious security bug in the flat file processing that SQLite does, which exposes the data. No database should ever be unsecure, and you should never consider anything that's unsecure. Because especially at the edge, it's vulnerable out there, sitting out there in an antenna, sitting out there in a car to be easily hacked. So secure edge computing is becoming a big trend because governments are going to come back and ask you to validate with regulations that edge computing is secure. Otherwise, they'll shut you guys down, right? It's an important trend. So putting it all together, this is what Actian can offer you guys. Actian Zen is a secure edge database which has the smallest footprint and all the characteristics that my CEO mentioned. Small footprint, secure computing, SQL access, Java or C SDK coding. So we have that as a Zen core embedded database available at the edge. And by the way, it runs on every operating system that you can think of. Desmond Tan, who runs the Zen program for us, he's going to talk about everything. It runs on an iPhone. It runs on an Android phone. It runs on a Raspberry Pi. Hopefully all of you are enjoying your Raspberry Pi, hopefully soon. It runs on Linux servers, Intel processor, everything. So the IoT problem that you guys are going to deal with can be solved through a small footprint database like Zen. Every little database that is out there or every device needs to talk to a mothership. So that's where the Actian Edge database, which is a consolidator of multiple endpoints, is something that you're going to use from us. And then for the operational data warehouse, we have Actian Vector and Actian Avalanche that can store petabyte scale, hundreds of billions of rows, and process data in a matter of seconds. We did a test. We did our own test. We loaded a petabyte of data into a cluster of Vector or Avalanche. And the total number of rows that we loaded was about 870 billion rows. We fired a query from hell, select count star from that table, came back in 4 seconds. 4 seconds. Think about it. You can access 800 billion rows in 4 seconds. That's the kind of compute that you need for an operational data warehouse. It's built for performance and reliability. And at the right, you see ActianX, which is our OLTP database, which competes with the likes of Oracle and SQL Server and so on and so forth. And at the bottom, we bring it all together through a data fabric. Remember the data fabric in the architecture I showed? We bring it all together in a data fabric, and Actian Data Connect can run on-premise, VPC or iPaaS or embedded, and this is how we connect all of the engines together. The whole concept is Avalanche, and Actian Universal Connect is how we make it happen. So in conclusion, thank you very much for attending this, but think about Gen 3 Cloud Data Warehouse as you go through, and hopefully you got something in terms of an architecture. But Gen 3 based cloud data warehousing is where the world is going and where the trends are pointing to, and the leading provider for that is Actian Avalanche. So please do give it a try, actian.com/avalanche. It's a free trial, and I would welcome any of the feedback that you guys might have. So thank you very much again for attending, and we'll move on to Desmond and talk about edge computing. Thank you.